Okay, so 4.1 and 4.2, well, first of all, 4.1 I don't have a video for, I don't plan to make one, but it's just on linear versus non-linear relations, which I'm going to explain a lot what the difference is in this section, so that'll kind of do 4.1 as well. But what we need to know is quadratic relations are non-linear relations, whereas lines are linear. So when we have like a y equals x to the 1, that's a line. Y equals x to the 2, that's a quadratic. So here in this definition, it says a relation whose equation is in the form ax squared plus bx plus c. As long as there's an x squared somewhere, it's a quadratic, okay? And like it's the highest power. It can't be like x to the 3 and then an x squared. So as long as the x squared is the highest power. These don't have to be here necessarily, right? They could be zeros. B and c can be 0. So we'll just have this, right? Okay, so linear relations make lines. Lines go forever, arrows both ways. We know that. Doesn't matter this way, this way, this way. These are all lines. A quadratic relation, we don't say it's a quadratic on the graph. The actual picture is called a parabola. Okay, it's called a parabola. And this is a U-shaped graph of a quadratic relation. These are examples of parabolas. Parabolas can either open up or they can open down. Those are your two options in parabolas. Just like lines can go like this or lines can go like this. Okay. Now, the most important part of a parabola is the vertex. The vertex is the point of a parabola where the curve changes direction. So take a look at this curve over here. It's going down, 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 down. Hits the vertex, now it's going back up. Or vice versa, it's going up, 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 up. Hits the vertex, now it's going down. So all questions are usually based upon the vertex. The solution is usually the vertex. How high did you kick the ball? What was the maximum height? What's the lowest cost of doing something, making boxes or whatever the case may be? Okay, we really only care about vertices. The axis of symmetry is amazing because when we graph a parabola, we really only care about one side of it, and then we use our knowledge of symmetry to just like mirror image a bunch of points, and we can move a little faster with symmetry. But I'm going to ask you questions, what is the axis of symmetry? And you're going to have to know that it's just exactly where the parabola is split in two. And it's very easy to know this when you have the vertex, because if you think of the x's and y's, right? If you think of the x's and y's, the axis of symmetry is going to be the x coordinate of your vertex, always. Very easy. Okay, but we'll get more into that when it gets there. Finite differences. In grade 9, to find out if something was a line and you only had a table of values, you could have found the first differences. Like, oh, first differences are the same, therefore it's a line. Finite differences are all differences. First, second, third, doesn't matter. So they're finite. There's not infinity of them. So these are differences found from the y values when you have evenly spaced x values. Linear relations have the same first differences. We know that from last year. Quadratic relations have the same second differences. So a quadratic relation does not have the same first differences. Okay, and over here we're just going to show how we know that from a table. Okay, but again, x to the power of 1, I know it's a line. X to the power of 2, I know it's a quadratic immediately. But sometimes I won't have the equation. I might just be given a table and I can determine if it's a linear or quadratic using differences. So, just as a reminder how to fill in a table, I can create these x values. I like to stay around the middle axes, right? If you're talking about a graph like this, I love this area because it's close to everything. It's close to 0. So I like to use -2, -1, 0, 1, 2. Doesn't mean you have to use that. You can use whatever you want. Just from my experience, I like to graph around the y-axis. Okay? I don't like to graph over here unless I have to. I plug the -2 into here, so I get 2 times -2 is -4, plus 1 is 1. I plug in a -1, I get a -2, plus 5 is 3. If you know linear relations already, you should know that you can use the slope to fill in the rest of the chart instead of plugging in. I know the slope is 2, and I know this is linear, even though technically we don't know it's linear yet, but to save some time, 5, 7, 9. I know I'm going to go up by 2. Now, what first differences are, which you should know, I go like this, and I subtract the bottom number from the top number from the bottom number. So 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5, 2. 7 minus 9, 9 minus 7, 2. Because these first differences are the same, this is linear. Okay? Even though we knew that from the equation, if this wasn't there, you probably still knew that because like, oh, it's going up by a constant amount, so it's linear. But the proper language should be first differences are the same, therefore it's linear. Let's take a look at this one. A lot of mistakes are going to happen here because we've never made a table of values with a parabola or with a quadratic. If you got a question in your homework and it says graph this, there should be no reason you can't graph it because we all know how to create a table of values. I can give you a grade 12 long function, long equation. You should be able to make a table of values, even if it takes you 10 minutes, and you can graph it, no problem. Very accurately too. Just plug in more numbers. You got an extra 5 minutes, plug in more numbers. It's for $1 million. Plug in 1,000 numbers and graph this thing perfectly. Okay? So when I plug in, I'm just going to show you one plug in. Please make sure every single time you're plugging something in, it's in brackets. Because you're going to be plugging a lot of negative numbers, and if you're not putting negatives in brackets, the square is not going to turn that positive. Okay, so be careful when you're on your calculator. If you just do -2 squared, it's going to tell you -4. But -2 squared is +4. This is 4 minus 4. This is 0. Plug in a -1, I get 1 minus 4, -3. Plug in a 0, I'm left with -4 because the x disappears. That's an easy one. Plug in a 1, 1 squared is 1. That's -3. 2 squared is 4. This is back to 0. Okay, so I've created this table of values, just doing the math quickly in my head because that's an easy equation. It gets pretty annoying when you have something like this. Still can do most of them in my head, but it's just like be careful when there's like an x squared and an x, because now there's 2 substitutions you have to do to make the table. That was just 1 substitution, a little easier. Erase this before we get confused. Okay, now let's do first differences. -3 minus 0. -4 minus -3. -3 minus -4. 0 minus -3. Be careful subtracting negatives. If you're thinking minus negative, just plus. 5 minus -7. There's 5 plus 7. Stop thinking minus negative, okay? Because a lot of you guys are probably like, whoa, that's -1. That's 1. Be careful. These are not the same. I know this is not linear. Let's go again. So these are first differences. Second differences. Now I do the differences with these guys. -1 minus -3, 2. 1 minus -1, 2. Ceiling's gonna come down soon. 3 minus 1, 2. Second differences are the same, therefore this is quadratic. Okay, so very easy to use a table of values. You kill 2 birds with 1 stone. You're able to graph it easily. Okay, I saw some guys on your tests, you're using a table of values to graph lines. Terrible, but I mean, if that's what you got, that's what you got for a test. Also with a quadratic, this is not going to be the way you graph a parabola after chapter 5. Right? We learned skills, very difficult skills with quadratics to make graphing much, much easier because table of values, this is just like if it looks nice around the y-axis. But if it's like √5/7 this way and like 3/0 down, that's undefined, but still. We're not going to be able to do that using a table of values. Okay, so we learned a lot more skills. Okay, so that's just 4.2, just like understanding what a quadratic is, what a parabola is, vertex, that's it.